Okay. Sorry, I had the wrong sheet out there. This is for Advanced Algebra 1, and this is starting Topic 2, Section 1, and I've divided it into two parts. One where we go over the vocabulary, and we go over how to graph, and then in the second part we learn how to write the equation of a line. So just some vocabulary. The coordinate system where we plot points. This is our x-axis. Can't see anything there. Sorry. This is our x-axis. The horizontal axis is the x-axis. The vertical axis is the y-axis. The point where they intersect is referred to as the origin, and it has coordinates 0, 0. This is my positive x-axis. So this would be positive 5. This is my negative x-axis. That would be negative 5. And we can put whatever scale we need to on the axes, which is our axis. The vertical axis is the y-axis, and heading north here, this would be the positive y-axis, and heading south would be the negative y-axis. Okay, this is quadrant 1, and we use Roman numerals to name the quadrants. This is quadrant 2. This is quadrant 3. This is quadrant 4. And notice that we go in a counterclockwise direction to name them. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. And then one of the things we're interested in with lines is what we call their slope. Okay. So if I imagine, here's my car. My car is going to drive across this piece of paper, and it has a front bumper, and it has a hood, and a windshield, and then it has a trunk, and a back bumper, and it has wheels, and it has windows here, and here, and here. This is a van. It's a big car, and this is my car, and my car goes left to right across this piece of paper. Okay, this being the front of my car, and this being the back of my car. So when I am looking at lines, and that's what we're going to be focusing on in topic 2, are lines and the equations of lines and graphing lines and everything to do with lines, the slope of a line, etc., and so on. When I'm driving across this paper and I have to push on the accelerator to get up that hill, any line where I have to push on the accelerator to get up that hill has a positive slope. Okay, so this line would have a positive slope. Any line where I need to slam on the brakes, slow down, or I'm going to get going too fast, gravity is going to get me going faster and faster and faster, I have to put on the brakes to slow down. That line is going to have a negative slope. Okay. And then if I have what we call a horizontal line, the horizontal line is like driving across Nebraska. Okay. It's flat. There's no uphill, there's no downhill, it's just flat. And the slope is defined as rise over run. So when I choose 2 points on this line, how much did I rise, how much did I run to get from one point to the other point? Same thing here. How much did I rise, how much did I run to get from one point to the other point? Well, for this line, I have 0 rise. This line is not going up or down at all, but it has lots of run. And so 0 divided by anything is 0. So a horizontal line, which is a y, let's say y equals 2 line on this one, the slope is 0. It has a numerical value. We can calculate it. We can pick the 2 points on here and we can calculate their slope. Okay. So the other option, the last option, the only other option, is that we have a diagonal line where we have a positive slope. We have a diagonal line where we have a negative slope. We have a horizontal line. And then lastly, we can have a vertical line. So this might be the vertical line, 1, 2, 3, 4, 5. So this might be the vertical line x equals 4. Vertical lines are x equals lines. Okay, this vertical line would be x equals 4. And the slope, this line has so much rise. There's rise. So we say there's all kinds of rise. Over 0, there is no run. The run is 0. I don't know if you've ever tried to take, like 5 divided by 5 on your calculator, but 5 divided by 0 on your calculator, but 5 divided by 0 is undefined. Your calculator will tell you that. Division by 0 is undefined. The slope of this line, it doesn't have a numerical value. There's no numerical value that I can assign to, 25 over 0 or 5 over 0 or negative 2 over 0. There's no numerical value I can assign to that. So we say that for this line, the slope is undefined. And in fact, this line has so much gosh darn slope, it's undefined. I can't ski down this mountain. I can't build a roller coaster with this slope. Okay, so it has so much gosh darn slope, it's undefined. The only car I know that can get up that hill is Batman's car, and it's right up. Okay, but so vertical line, the slope is undefined. Horizontal line, the slope is 0. And then these diagonal lines, the slope could be 2. The slope could be 2/3. The slope could be negative 3/8. We assign a number and there's a way to calculate that number. So when we graph these lines, okay, some of the things we're interested in, and say we have a line y equals 2x minus 3. Okay, this is slope-intercept form. And if we're in slope-intercept form, which is y equals mx plus b, I can look at this line and I can tell you the slope is 2, it's the number in front of x, and the y-intercept is negative 3. And we can use that information to actually graph that line. And I'll show you how to do that momentarily. So the slope is the number in front of x. It's m. We use m for slope. So the slope of this line is 2. And the y-intercept is b. This is the y-intercept. So my y-intercept is 0, negative 3. For the y-intercept, x is 0. We put in 0 for x and we find what the y is. So if I put in 0 for x here, I get 0 minus 3 is negative 3. So the y-intercept is negative 3. We can also talk about the x-intercepts. Or in this case, the x-intercept. It's a linear equation. So to graph this, I start at negative 3 on the y-axis, which is here. And then I use my slope. Slope is rise over run. So the slope of this line is 2. And that's 2 over 1. So from here, I'm going to rise 2 and run 1. And I can rise 2 and run 1. And I can rise 2 and run 1. And I will continue to land on that line. I can rise -2 and run -1. I still land on that line. Okay, it's not very good. I'm not. But anyway, there's the graph of that line. To find the x-intercept, where does it cross the x-axis? I let y be 0, and I solve that equation for x. So I add 3, I divide by 2, and this point is at 1.5. And so the x-intercept is 3/2, 0. Okay? And I've got several examples to go through here. So we will do that. So as I said, slope-intercept form of a line is y equals mx plus b. M is the slope of the line. B is the y-intercept. Okay? So to graph this line, be a little creative here. To graph this line, I start with the y-intercept. The y-intercept is 0, -3. It's that number out here. And the slope is 2. So let's see, 0, -3 is here. And then I'm going to rise 2 and run 1. Rise 2 and run 1. Or I can rise -2 and run 1. Rise -2 and run 1. And then there we are. There's that line. And graph them all just exactly the same way. The y-intercept here is -2. And the slope of this line is 1/3. So I start at 0, -2. And then I'm going to rise 1 and run 3, both in the positive direction. Rise 1, run 3. I could rise -1 and run -3 because a negative over a negative still gives me a positive. Then our answer isn't the dots. Our answer is the actual drawing in of that line. So that's our answer. Our task is to graph the line, not the dots that are on the line. So the dots just tell me where to draw the line. Okay. This one, my y-intercept is 0, 2, and my slope is -1/4. So 0, 2 is up here. Negative slope, so I'm going to go down 1 and to the right 4. The slope is -1/4. So I went in a negative direction and then in a positive direction, because a negative over a positive is negative. I could have also gone in a positive direction and then in a negative direction. But what I do is, after I draw this line, I look at my equation and I say, okay, that's supposed to have a negative slope. Am I going downhill? Does this line have a negative slope? It does, so I probably graphed it correctly. And I do the same thing here. This line is supposed to have a positive slope. Do I have to push on the accelerator to get the car up the hill? Yeah, so that line has a positive slope. Okay. always throw people off. I'm not sure why, but it's just y equals negative 2x. And we get to this, and this is like the simplest line to graph, but we make it so difficult. And the reason is it looks different. Where's the plus b? Well, it's not there. So what number represents something that's not there? And the answer is 0. So this is the same as y equals negative 2x plus 0, which means then that my y-intercept is at 0, 0, which is the origin. So I put my first point, 0, 0, the origin, and my slope is negative 2. So I'm going to rise negative 2 and I'm going to run positive 1. And I can do that again and again and again. I could have also risen positive 2 and run negative 1. At the end of the day, I want that line to have a negative slope. I want to be going downhill, got to slam on the brakes so that I don't get a speeding ticket for going down that hill too fast. Okay, so there we go. Then, for some reason, we make these difficult as well. Y equals 3. You remember when I talked about it, this is the graph, this is a horizontal line. And it's a horizontal line going through 3 on the y-axis. So where does y equal 3? Y equals 3 right here. Where else does y equal 3? Y equals 3 everywhere along here. Okay? And everywhere along here this way. Alright? So y equals 3 is this horizontal line through 3 on the y-axis. That's its graph. The slope of that horizontal line is 0. The y-intercept of that horizontal line is 0, 3. That's where it crosses the y-axis. Then we move on to x equals negative 2. X equals negative 2. Recall from when I went off script and went over some of these things, this is a vertical line. And it's the vertical line through negative 2 on the x-axis, which is right here. And no matter what y is, x is negative 2. X is negative 2 here, and here, and here, and here. And so it is this vertical line through negative 2 on the x-axis. There is no y-intercept. And where does that cross the y-axis? It does not. There is no y-intercept. There's an x-intercept now. Well, there was on the other lines, the diagonal lines as well, but let's find it. The x-intercept would be negative 2, 0. And recall, the slope of this line is undefined. The slope of the vertical line is undefined. Okay? So, how do we graph this? Where do we start? We start at y equals negative 3/5 x plus 4. The y-intercept, because we're back to slope-intercept form, is 0, 4. So we start at 4 on the y-axis. The slope of this line is the number in front of x, so it's negative 3/5. So I'm going to, from here, I'm going to rise negative 3 and I'm going to run positive 5. And there we go. Okay. And then I can rise negative 3 and run negative 5. It's not going to fit on my graph. I could have also risen positive 3 and run negative 5 and landed on my graph as well. This line's supposed to have a negative slope, and if my car goes across this board or this paper, I would have to slam on the brakes from getting that speeding ticket as I go downhill. That's pretty much it. There's very few, there's not very many questions in the online homework on this. So we will be doing the worksheet as well for this section where the problems are going to be all mixed together. So that would be your next task.